Okay. So I just want to look at what we did last time. So when we're talking about slope, some of this we talked about last class. First, your parameter, what we're using in this unit. Your parameter is beta. Okay? This is the true slope of whatever our regression line is that we're looking at. Okay? So remember, we've talked about parameters versus statistics. Like you had mu was the parameter, and then x bar was your stat. Sigma, s, that's old stuff. So now beta is our parameter. The statistics that goes with that is b sub 1. So this is an estimator of the true slope. Whereas the parameter, remember, these are the truth. All right, we talked about conditions last time. Remember these first four? You're looking for a randomly scattered residual plot. And then the last one, it will just be randomly stated or randomly assumed, what you're looking for there. So we still have confidence intervals and hypothesis tests, just like we did before. Now we're doing them for slope instead of for means. So just a reminder, when we did means for confidence interval, remember it was x bar plus or minus t crit times s over square root of n. For slope, it's that same idea. Instead of x bar, what do you think I'm going to use? Yep, b sub 1 plus or minus. It is still a t value, so it's still a t crit. And then you're going to use standard error here, which I'll show you where that comes from. Degrees of freedom is always n minus 2. And guys, there's two ways we're going to do our confidence intervals and hypothesis tests. One will be from a computer printout, and that gives you all the pieces that you need. The other is where you're actually going to enter all the data into your calculator and then run the hypothesis test or calculate the interval all from your calculator. Okay, so we'll go through both ways that we can do that. All right, when you're doing your hypothesis test, you still have a null and an alternative. So your null is just that beta equals 0. The alternative could be beta is greater than 0, less than 0, or not equal to 0. Depends on the wording of the test that we're looking at. So a little side note here, we use beta equals 0 because this means no association between x and y. It'd be like your scatter plot of your data points is just a big cloud, and so your regression line has a slope of 0 because there's absolutely no association, positive or negative, between the two. If it is somewhat linear, then you can find a slope, either positive or negative, through those points. Okay? But again, we're looking at linear stuff now. Your t is b sub 1 minus b, beta, sorry, over standard error. That's your test statistic. Remember, it's always the statistic minus the parameter over standard deviation of statistic, which is your standard error in this point. Okay, so this stuff like this should look familiar to you. Okay, this is what you've been doing for your test statistics in the past. We're just now looking at it in terms of slope. So up next, guys, let's look at this computer printout and figure out where all of the pieces of information that we actually need are given to us in this. All right, so first, we've got some coefficients. And you're told constant and foot length here. Okay, so this 106.92 and 2.044. One of those is your y-intercept, one of them is the slope. Which one do you think is which? What'd you say, David? Yep, the 106, that's just your constant, so that's your y-intercept, or your b sub 0. The 2.044, that's the coefficient of foot length, which is your variable here, so that's the slope. All right, standard error coefficient. We had standard error in a bunch of our formulas up there, so we have to use one of these numbers. Do you think I want the one for the constant or the one that deals with the slope? Slope, everything we're doing is slope of our regression line here, so the value you're going to pick out from this is 1.153. All right, you also have a t and a p here. So the t is your test statistic. So that's your... And then the p, that's the p-value you would get at the end of your hypothesis test. Again, do you think I want the ones associated with the constant or with the variable of the slope? Yeah, the second one. So the 1.77 matters, and the 0.10 matters. Okay. All right. We've talked about r squared before. R squared adjusted you're not going to use. Let's write our least squares regression line from this computer printout, okay? We don't actually know what both of our variables are here. We know we've got foot length, but we have no idea what we're trying to predict from foot length. So I'm just going to use a y hat. And then what do you think I'd write for my actual equation? How do we write an equation of a line? Yeah, what do you think?
Like the V1, would you just write it like a regular line, right?
Yeah, so remember, this was last unit, this whole b sub 0 plus b sub 1 x, right? Yeah, so for us, we're going to do 106.92 plus 2.044. And we know we're talking about foot length, so I'll put that in there. Okay, just basic plugging in your y-intercept and your slope. It's like y equals mx plus h. Okay. All right, let's look at we wanted to do a significance test for slopes. So what that's talking about is a hypothesis test, okay? You can write your null and your alternative, and then the things that are going to matter. T is equal to b sub 1 minus beta over standard error. So let's look at that from our printout. What was b sub 1? 2.044. What do we use as our beta if we're doing a hypothesis test? 0. Good. So remember, that's always going to be your null, is that beta equals 0. All right, divided by standard error. What number do you think I'm using as the standard error out of this printout? Yep, 1.153. And if you actually type that into your calculator, what do you get? .77, and look, wasn't that given to us? Yeah, okay. So it's there. I'm not making it up, I promise. It works with the formula. So that's how you get your test statistic. Then our p-value, you could use your calculator to find this, but it's given to you as your 0.100. So you could base your conclusion on rejecting or failing to reject, depending on what your alpha level was from that. Okay. Then let's look at our confidence interval, how we would do that from this printout. So confidence interval per slope. Okay, remember it's your point estimator, which was your b sub 1, plus or minus your critical value times standard error. So plus or minus our t-crit times our standard error. So for what we've been given so far for this confidence interval, we could do the 2.044. That's my b sub 1. Don't actually know the t-crit just yet. But what am I going to plug in for standard error? 1.153. We're using that again, yes. Okay. So we need more information to actually calculate what kind of confidence interval we're looking for. But those are the pieces that you actually pull from the computer printout. Okay, so those are the ones that matter. Mm-hmm. Constant what? Sorry. Oh, the T and the P?
Yeah.
Nope. You need the b sub 0, like you need the y-intercept, but other than that, you're not going to use any of the ones for the constant. Okay. All right, okay? All right, guys, turn the page if you don't have any more questions on that one. All right, so we have sleep and GPA. Okay, guys, so what I want you to try to do, I want to give you a minute to do one. I want you to think about checking your conditions. We are going to do a t-test for slope here. Do you think you need to name what test you're doing? All right, so I want you to check your conditions, write your null and alternative, and then let's stop there and make sure everybody's okay with those. Wait, I thought before you said you can trust.
No, he does. He trusts like this half of the room. He like thinks this half of the room is incompetent, and then that little room over there is
Good job, guys. So what are we looking at? Like, what's the most important thing for checking your conditions, guys? Yeah, okay, knowing what you're checking, that is step one, yes. Remember that whole L-I-N-E-R. Okay, yes. Start there, and then what do you use to check almost all of those conditions? Yeah, speedy. You should write out what L-I-N-E, all of them stand for, and then you can just do residual plot is, you know, whatever for this part. Give it back to you, but I don't think so. Do you remember how to make a residual plot? Yes. Yes. Each other. You have to start by putting in some data. So you've got the computer print out for all the stuff you need for the hypothesis test, other than the condition checking, okay?
Has there ever been a question where it checks so like if you check
the answer is yes.
Truly, like, the only other word is if a question is what to do to linearize data. You know, like the first part we did like 2 times. So that would be the only thing. If you plot it and you see that it's then you have to straighten it. You can't do regression.
You can check condition for the
Most of these questions where it's like a hypothesis test and you go together, so you just do it once. It is.
just a writing. Is it really writing?
Yeah. Take every point you can do.
Well, it's usually better than the ambulance test.
Oh, okay.
Oh. You might be thinking of physics. No. Oh, I don't know. The debate is between that and inconsistent, but like,
How do you guys find residuals? Who remembers?
oh, like your like
Right.
find your line. And then you store your residual and I agree that there's a stone before that weight.
Talk to each other. See if you can remember how to get your residual plot.
Oh, you did. That's why it's wait.
Yeah, that works. Yeah, first I was like,
So, I'm not even a scatter plot.
actually,
I don't know how to do
okay. So you can remember this.
it. I don't remember.
Try to figure out your position. Again, it's kind of a crucial step.
And then you put in the list.
You have done
And then you
this.
press that. And then for your, when you get one.
Wait. I know. I seriously want to know. Really long, yo. Here was some great. It goes into my nose.
So sometimes you're gonna have to write the book, but
Actually.
everyone's gonna have one. So if you look at the last one. Yeah, so and I'll show you where that is. Shows up as usage. So guys, if you forgot how to do,
Stat.
if you do second stat, it takes you into names.
Yeah.
You see the first information for 7, it says resid. You take that and then store it in list 3. You should have your residuals in list 3.
I got your.
So I did it for you. You got okay, so not in here. Like on your home screen. Store in list 3. Is it a beautiful cloud? Oh, that is a beautiful cloud. I like
Wait,
it.
how do you view it?
All right, guys, if you're not getting your residuals, let's go. Got them?
We did it. No, I don't know what's up.
Did you have to?
She knows how to do it.
What do you do? You store it as L3 and then you.
Mr. Lake.
I was pressing clear, not down. It's cloudy-ish.
So how do you find it? Wait, that's right. If you do this one, I listen to. How do you like that?
Oh, wait, I think, well, that's what, this is what mine. So then you just, looking at it after you start in the.
Is that what you think how that's for the okay.
How long do you wait?
I don't even know. I don't know what's the
There we go. So you have to actually do the refresh.
You're welcome.
I forgot to redo that when I finished that.
No, I don't know.
That's why.
Yeah.
Okay, so.
No.
That's just.
Right now you don't really have to worry about it. All you need to know is if you, I know that sounds terrible.
Batty wing. Yeah, you guys are hacking. You're just eating bots. How do you find diamonds?
Significance test is a hypothesis. Yes. All right, so you guys get residuals. Residual thought, no. Yeah.
Oh.
Okay. Step one, put them in.
I don't understand why when you put it in this tree and then you just drop it, it automatically knows.
So what you're trapping. So you, yeah.
Okay, that's, okay.
You have to change that.
I needed to change something. I didn't know what it was.
Very cloud-like, right?
Yeah.
Yeah.
Thank
Okay.
you. I knew something wasn't right and I was
Yeah,
like,
no, I'm missing a step, I know.
stop lot.
Oh, that's why. Why?
Your residuals in this three, that was three graph.
That's why.
What does this one say as that?
Oh, that different. So obviously I just don't know.
So this one, oh, is it? Yeah. And then here's your outliner. Okay.
You guys have a cloud?
See,
Do you have a list?
I Nope. What am I doing wrong?
Guys, I'll pull up the calculator here so we can look at it, okay?
That doesn't make sense.
Oh.
Yeah, you haven't used it.
Yeah.
Stop following.
Yeah. Yeah, that's what I'm saying.
You have the values.
I do. Yeah. I haven't seen.
Either way, then if the values written on it still come up.
Yeah. That's not.
Yep, I'm gonna show you.
I just have like an error coming up.
You're special.
When I already have it in like one and there's three and then everything.
Why does this one stay the same?
Because you're programming it for the other side. But it's still like, oh, this thing is I just read it for you. Okay, guys.
That's how.
Quick refresher on your residuals. So first, you got to put in your data. Okay, data's entered. Guys, you have to actually do the linear regression before you can find the residuals, okay? So I'm going to calculate my linreg. Right now I don't even care if I store it. I just need to calculate it so that the residuals actually will exist somewhere. Then, second stat takes you into the list. See that number 7? I need to calculate my residuals, and I'm going to store it in list 3. Okay? Your first residual should be 0.2365. If you are not getting that, something's not going right. I can then go into my scatter plot. Make sure it's on. Do I want to plot list 1 and list 2 anymore if I'm looking at the residual plot? No, I want to plot list 3. Okay, I'm just going to hit zoom 9. What a lovely cloud, right?
Which is a good cloud.
It's a good cloud. It's a beautiful cloud, right? Okay, guys. If you are not seeing this on your calculator or you missed a step somewhere in there, please let me know so I can help you to make sure you can do the residual plot. It's important for finding this, okay? See where we are. Yeah.
Sorry. This is necessary.
Okay, perfect. That one's good. Because you're still plotting it over the same time. All right, anybody else? Yes.
Wait, it's not.
Oh, okay.
You got 6 on it? Sweet. I guess I'm going to That's easy. That's
Wait, so like this
I really hope not. At least just gonna forget everything. But I have to write everything down.
You're not confused on this, right? Okay, so then you're good. All right, so let's look. Let's see, where did I put my data here? All right, so conditions we were fine on, right? You do have to state linear, independent, normally distributed, equal variance, and that's all. Residual plot was a cloud, random cloud-like shape, okay? We get all of that, right? And then random, was it stated? Yes? Okay, so conditions, are we fine? All right, I'm not going to write all of them because you guys know it takes a while to write them. What is my null? Okay, beta equals 0. My alternative, what do you think? Yep, because it doesn't say necessarily, it just says, is there evidence of a linear relationship? So that could be positive or negative. So we're just going to say not equal to 0. Okay, one thing you also need to do on this is actually define what beta is. Okay, so we need to say beta is the true slope of the regression line or you, if you want to do it, that's fine. You can just sit somewhere else for now. That's fine. Let's see. Predicting GPA from hours of sleep. This is where that context comes in. You've got to make sure you're telling me all of this, okay? All right. To actually do the hypothesis test, we need our test statistic, which I know they gave it to you in the computer printout. I'm just going to write the formula. Remind you where those values came from. The ones we would use are the 0.10. Yeah.
They always cancel us.
No. So if you look at if you're given the computer printout, yes, it should be in there. If you're just given data like you are there. And this is going to be over 0.04387. What do we know we're going to get if we actually divide that out? 2.32. Now you could look and do this on your calculator to get your p-value, but do we already know the p-value? Yeah, it's given to us. What is our p-value? 0.038. Okay. What are you going to tell me? What do we say now based on alpha of 0.05? What'd you say? Yes. So since our p-value of 0.038 is less than alpha of 0.05, we reject the null. So guys, that sentence, is that anything new? No, it's the same stuff you've been doing, okay? There is enough evidence to suggest that there is a linear relationship between hours of sleep and GPA.
Basically, what the equals from your test program. You don't have to basically show it to you or anything like that. You just have to write down the conditions and what age on the state.
Yeah, define beta.
Yeah.
Come to your conclusion. Yes. Yes.
Do you want to just say like beta is not equal to 30, or do you want to write like the actual value?
So if you in your null and alternative say the true slope of the regression line blah, 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 is like 0, then you don't have to define it over here. If you can just use symbols over there and define it once.
Okay, but we're not putting like the 0.10197 into our null.
That's not beta. We always use beta
Oh,
equals
true.
0 because that would mean there's no association between those two. Okay. Questions, guys? The conclusion, is that easy? Like, is that the same as what we've been doing? The context is exactly from the problem. Does it provide convincing evidence of a linear relationship between hours of sleep and GPA? Evidence to suggest that there is a linear relationship between hours of sleep and GPA. It's all given to you in the problem, okay? You just have to write it in a coherent conclusion. All right? Okay, let's look at number 2 on this. We are now going to make a confidence interval with this stuff. Okay, so they're asking us for a 95% confidence interval. So we need B sub 1 plus or minus T crit. How many degrees of freedom do you think we would have this time? How many 12 degrees of freedom. Yes, why? There's 14 points that we're entering, 14 data values, and it's always n minus 2. Okay, and then times standard error. So, what is B sub 1? Can you see it okay, Elsa?
No, I can't.
Okay. B sub 1 given to you in your computer printout. What do you think? Yep, 0.101, what was it, 97? Okay, critical T value with 12 degrees of freedom. Do you remember how to find that? So back to it is inverse T. Okay. Where's the inverse T, guys?
That's your second bars, right?
Second bars.
Mr. Dister memory, right? Okay, inverse T number 4. All right, now we got to think about what we're actually putting in here. Yes, 100 minus 95 divided by 2, okay? Because it's split evenly between the two sides, so 0.025 is the area I'm actually looking for. All right, degrees of freedom. 12. And then enter. Now this, I get negative with that. Does it matter? No, because the negative is the one on the left, the positive is the one on the right. It says plus or minus anyway. So we're using this 2.179. It's close enough for me. Is everybody okay with where that came from, that inverse T? Okay. So it was 2.179. And then time standard error. Well, that's also given to you in your computer printout. What is it? 0.04387. So I'll make a little side note. Inverse T for T crit. All right, so now it's just a matter of you actually adding and subtracting this. What are the two values that you come up with? That is a plus or minus. Anybody have any values for me? Yes, back up.
.00639 is the
I have
one.
0.007. 0.006, okay. I just wrote down the wrong thing. 0.006. So it's 6.3, yeah. All right. And then what about our other ones?
.19755.
197 or 198? What'd you guys have? So 19. Okay, we'll write all of it so you feel better. Actually, I'm gonna make it 198. How about 0.198? Yes? Okay. Okay. So is everybody okay with coming up with the confidence interval? Remember how to write a conclusion about a confidence interval. What do we say?
We are 95% confident that the true GPA of
Not quite the true GPA. I like how you started though. We are 95% confident.
the true slope of the regression of the GPA
true-
is between 0.006 and 0.198.
Slope of the regression line.
Predicting GPA.
Yes, for predicting GPA. Good.
No, it's new. Use this as a picture of me.
For predicting GPA. From what? Okay. From hours of sleep is between 0.006 and 0.198. Okay? Does that make sense? Again, all very familiar stuff, just now we're talking about slope. Elsa, do you need me to read any of it?
No.
Are you sure? Okay. We're going to skip 3 right now just to make sure we have time to get through the ones that you have to do it on your calculator completely. So we might come back and see. Questions on this thing? Okay. I see some frantic writing still. All right, guys, let's go ahead and turn the page. We're now looking at SAT scores. All right, so you've got their math score and their verbal score. We want to know, is linear regression appropriate for the state set?
That's the LM.
Yeah, so like it's looking at the scatter plot and seeing, does it look like it's linear? Like step 1, guys, is just looking to see, does it follow a linear shape or is it some sort of weird curved pattern? Like I would say, yes, the scatter plot appears fairly linear. Like that's what you're looking for there, okay? Then the conditions, that's when you look at the residual plot, which is sort of like reaffirming what you answered in part 1 or part A here. Okay? So guys, try the first 2 for me. Let's make sure you're good at the residual plot. You can also give me the equation for the least squares regression line. And then we'll get to doing the confidence interval on your calculator, okay? You're okay. Okay. Well, that's good. But which one? I think everybody forgot which one. So I'll let you scatter plot. All right, guys, it's a day value for you guys. You're on to this one. Remember, you have to calculate your line regression before you do your residuals. Otherwise, it has to be your
Yeah.
Why do you have to do it?
So, what is right? Which comes from. So if you don't have that line, how do you know what the prediction value is?
Well, so it doesn't just calculate it out, sorry.
You need to be like, here's my line. Now, based on these data points, where, what is the, so it has to know like,
But if you do it for the, is the linear regression appropriate, you don't even have to get to it. It's probably not working.
yeah, because you did it, I mean, you did it.
Yeah.
Okay. Yeah, acceptance.
Oh, like there's not graphs.
Yeah, the plot looks kind of linear. Did you look at it yet? Okay. Yes. All right, and you calculated the regression. Okay, remember that. So, the weird part. No, that's okay, I'm gonna go through the residuals. Alright, so what we have to do is we go into the list for a second.
Slowly.
Everyone forgot what that was. And then we want to store it.
Yeah, why this is gonna be verbal.
Now store the residuals. So like it calculated all of the residuals. And they are now like if you look back. So there's your list. This is your residuals. So the section
Not me. I'll tell you that much.
Well, looking at that, or a stat plot. And instead of looking at those two, we go through three, and then we want to see. Pretty much very good. Lunch. Okay, so that is step one here. So yes, scatter plot. It is approximately, roughly, anything like that. Okay, conditions. You had to go through linear, independent, normal, equal variance, random. So the first four guys was the residual plot cloud. Did we do okay calculating the residuals and finding the residual plot? Yes, no, some sort of, yes, okay, was it cloud-like? Yeah, you only have, what, like 10 data points this time, so it's not going to be the beautiful clouds that we had before, but you should just say residual plot is random and cloud-shaped, okay? Okay, and random was stated, right? All right, and then your equation, you should have had predicted verbal score equals something like, was it negative 46? Hold on, 0.42. Plus 1.16 math score. Do you agree with my numbers? Yes, okay. So is everybody all right to that point? We got that, okay. And again, do the context when you are doing your equation for the regression. Okay, so now we're gonna do the 90% confidence interval. So you are not going to have to do the formula. Like, you're not going to have to find these pieces by hand. I'm going to show you where it is on your calculator. But just to remind you, write out just the formula. Degrees of freedom was what, 8 this time, I think? Standard error. So, what we're going to do on your calculator is the ln reg t interval. That's where we're looking at. Okay, so let me pull the calculator really quick. All right, guys, if you go to stat and then test, do you see these? These are way at the bottom of your list. There's linreg t-test and linreg t-interval. Does it make sense since we're doing linear regression? Those are the ones we're looking at. We're doing the confidence interval, so I would pick t-int. Stat. And then it's like way at the bottom. What do you think? We are doing the interval right now, so I'm not decided yet. So I'm going to pick t-interval. Okay. Do you have your data in list 1 and list 2? Yes. Okay. Frequency, we don't have a frequency list. You can just leave that as 1. Our confidence level is not 95. What is it? 90. So I'm going to do 0.90. If you want, you can store the regression equation. It's fine if we don't for this one. And I didn't actually do my regression, so we'll see if it'll work for me. I think it will. Okay. All right, guys, so it gives me my interval, it gives me my degrees of freedom. You don't need to worry about the rest of it yet. That is your slope that you found when you did your regression equation. Are you getting 0.847 to 1.47? Yes. What would we then say? What's my conclusion going to be? We are. Good start. 90% confident that the true, and what are we talking about now? Slope, yeah, so the true slope of what? The regression line what is this, a regression line for, or, okay, so for predicting SAT verbal scores from math scores is between 0.847 and 1.47. Okay. We all right with that? Again, conclusion, it's the same type of conclusion you've been writing for a while now. All right, so your calculator's going to help you when you have to do it with the list. All right, let's look at the next one. If you got stuck on this part and didn't find this on your calculator or something went wrong with your test, let me know. The next one up here. All right, so now you've got some car info. Very well aware these are really old cars. So I want you to go through, is linear regression appropriate? I want you to check conditions for me. Find the equation of the least squares regression line, and then, guys, I want you to try to do the hypothesis test. So instead of Linreg T interval, what do you think you're going to pick? Linreg T sets, yeah. Okay, if you're having calculator trouble anywhere, let me know. Okay, interesting.
Really hindering the first. No, it's just the number of
Sure.
we're not big.
I sit in the back.
Guys, if you have your Unit 8 homework quiz corrections, I will grab those.
Yeah, we're just trying to make it one.
Okay.
Whoa, that is not.
Everything else I use
Well, the only
for when I'm doing the
homework, okay. Yes. What?
This is roughly an hour.
Oh, thanks. Yeah, it's not real great, but we're gonna go with it. It's what? So, look at your result button. How does that look? Homework? Yes. That's Anybody else here? We're gonna pretend it's linear enough, guys.
Do not normalize.
Okay, so you look at the slot three, and then we're turning right, so you can
Not only is it, they're giving good art, when you decide.
I was using cotton.
So,
It's like,
Think about it, that's cool. It's not gonna deal. But you want to be. Not ever, literally.
Oh my god, I can't.
So when we like
But if you do the test, you don't.
There is not.
I want to be able to like see
yeah.
Sounds like the consultation
Fair? No, that's not okay.
I did overshoot. Aiden was screwed up with all the years that we.
Hey,
They won't turn on, start pressing start. So so this is the way.
I don't think I agree with it. I'll look at it. If you want to see. Well, I mean, it goes on before, but.
So we're looking to check to see if they're not right in this type of problem.
If there's no relationship to
So are
data,
we proving that there is a relationship, or are we trying to find out if there is a relationship?
I know. Okay, so
So if p-value is lower, then we do not have evidence to support that there.
the null indicator, so there.
So if p-value is under, yeah, okay. Yeah.
Yes, it's it.
Yeah.
All right, guys, let me go. What? So Not if they're actually asking you to do a hypothesis test. If they're asking you just a general question, is it linear or not? This would not be. Like, this is not great data at all. Okay. Okay, guys, I want to go through what you should be writing here for this hypothesis test. We got about 10 minutes left. So first, you need your null and your alternative. Did everybody do beta equals 0 and beta does not equal 0? Okay, and what is beta? Okay, the true slope of the regression line. Predicting car year. Miles driven to work. Okay. So guys, even if you had no idea how to do the hypothesis test, could you write the null and the alternative? Could you define beta? Could you do your conditions? Right? These are the free points you need to just steal as many as you can on the AP exam. Right? They are there for the taste. Okay. You also want to say we are doing a t-test for slope. So somewhere in here, you want to name that t-test for slope. Okay. All right. What did you get as your t? And I write the formula again because everybody loves the formula. What did you actually get from your calculator? 1.095. Excellent. Which gave you a p-value of 0.302. And guys, go ahead and just tell me degrees of freedom. It was 9. Okay. All right. Now all you have to do is write your conclusion. What would you say? Yeah.
How do you subtract by t from degrees of freedom instead of 1 for this?
When you're doing regression, that's just the rule that you follow.
Always minus 2.
Yep. And with slope, it's always t. Like you're never going to have like a z interval for slope. It's always going to be t. Okay. All right. So since our p-value of 0.302 is what? Is it greater or less than our alpha? Yes, greater than alpha of 0.05. What do? We fail to reject, okay? There is not enough evidence to suggest there is a linear relationship between work and car year. So guys, think about your conclusion. When you started this problem and you looked at the scatter plot, it didn't look like a great linear model, did it? So doesn't it make sense that we're saying, well, there's not enough evidence to say that you can accurately predict car year from miles driven to work? Okay? That's how it all connects. Like, that's what the hypothesis test is doing. It's saying, does it make sense? Is this a good linear model? No, it's not. Okay, so that's why we're going to fail to reject. Okay? Are we okay? All right, so what to do next time, guys? Data journals, and what else will be happening? Concept quiz. Guys, don't forget all the stuff from Unit 8 about slope as well, like interpreting slope, R-squared value, all the stuff you did on the Unit 8 test too. Okay, it all connects with your Unit 9.